Hello, my name is Robert Millikan. Today I will be talking about my famous Millikan oil drop experiment. The way my experiment worked was I had a chamber in two parts. In the top part, I sprayed a mist of oil, and it would be above a pair of parallel conducting plates. In between these plates was an adjustable electric field. That's how I measured all the oil droplets and conducted my experiment. The oil droplets would then fall through a small hole into the electric field in between the two plates. On one side in the lower chamber, there was a hole where an intense light was shown through it. That way it would charge these electrons and hit them to where I could observe them through a microscope. This way, by observing them, I would find the terminal velocity whenever the electric field was off. I could do that by turning it off. As I said previously, it was adjustable. By getting this, I now had the radius of the drop, therefore giving me the mass. Since I already knew the density, I calculated it through that. I then turned on the electric field to where it would balance the force of gravity. By observing these drops, I was able to figure out the charge with the previously found mass and the force of gravity through calculations. The charge of the drops was configured to be multiples of 1.602 times 10 to the negative 19 coulombs for each drop that I observed. Each one was a multiple of that number. This was the charge of an electron that I found. So what I was trying to do was find a more precise measurement of the charge of an electron, because J.J. Thomson actually found the charge of it in 1897 as he discovered the electron. I just didn't think his value of just 10 to the negative 19th power was the most accurate value for the charge of an electron, and so I set up to do my own experiment and to dig a little further. My experiment was done at the University of Chicago. I was teaching there at the time. Around this time, I remember that William Howard Taft was actually inaugurated as the 27th President of the United States on March 4th. And on the 1st of March, I remember the first university school of nursing in the United States, the University of Minnesota, was established. As I've mentioned, I was teaching at the University of Chicago, and one of my students was actually involved in the project as well. His name was Harvey Fletcher. He played a pretty important role in helping me with that experiment. My role, however, was kind of the head of the project. My job involved constructing the device, observing the oil droplets, and calculating all my observations to find the charge of an electron. I was basically the leader of the project. That's why it's named after me. My impact on the physics community was that I found the constant charge of an electron. That charge is a constant and can be used for every electron. In this way, I also affected many other fields of science like chemistry and electronics. That charge is used in many formulas today. About my aforementioned partner / student, Harvey Fletcher, Harvey actually played a huge role in deciding to use oil droplets instead of water, kind of like how J.J. Thomson did for his experiment, because in his experiment he dealt with electronic and or electric and magnetic waves, but in his he used water droplets. The only problem with water droplets would be that from my experiment, in my case, whenever it would drop through, it would evaporate, and it wouldn't give me enough time to observe each water droplet very carefully in deciding the charge of an electron through that. And so Harvey actually played an important role in deciding to use oil at the time, and so I have him to thank for that. and it allowed me to observe each of the water droplets for an extended period of time to get accurate results as I repeated it multiple times.